Hello guys, welcome back to Maths on African Motives, still on mathematics, grade 12. In this platform, we are going to focus on question number 1, that is on our algebra. We have got question number 1 that we are going to focus on, particularly from the question paper, which was written in September 2020 from Eastern Cape. That is Eastern Cape paper. So we have some questions which are pretty nice to work with that we are going to consider on question number 1. We have good questions, and it was actually having 26 marks. So we're just going to focus on question number 1 here. All right, so without wasting much time, we've got the first question that we are given, 1.1, solve for x. So all these equations and also the inequality that we have, we are solving for x. So we've got the first question. So I'm just going to write it aside so that we can see actually what we're supposed to do. All right, so that's 2x squared plus 3x minus 3 is equal to 0. That's the first equation that we are supposed to solve, 1.11. All right, so 2x squared plus x minus 3 is equal to 0. That's a quadratic equation. We've got the highest exponent in this case, or the highest power being 2. So as long you are not given to give your answer to 2 decimal places or to 1 decimal place, that type of a question or that type of a quadratic equation, you can solve by factorization, it will be having factors. Yes, you can use a quadratic formula, but you can attempt by factorization. So I'm going to attempt using both methods. In this case, let's start by factorization. Since the coefficient of x squared is not 1, that means we are going to be forced to multiply the first term to the last term, 2x squared times minus 3, which is going to give you negative 6x squared. So your focus is to find the factors of negative 6x squared. Factors, we are referring to two terms that when you multiply, they will give you negative 6x squared. But if you add those factors, they must give you the middle term, which is x. That's 1x. All right, so we've got factors such as 2x and negative 3x. All right, if we multiply this, we've got negative 6. If we add, we have got negative x. All right, if we add, you have got negative x. So what you're going to do is to just vice versa the signs. So this time we can have it as negative 2x and 3x like this. All right, so let's see what happens for this one. If we are to take it this way, we have got negative 2x here and positive 3x. If we multiply these two terms, we get negative 6. If we add, that's a positive x. That's negative 2 plus 1. You are adding negative 2 plus 3. That's a 1, which is 1x. So these are the factors that you're going to work with. So it's not like these are the only factors. No, there are so many factors. You just need to try. Even if you use negative 6x and x, if you multiply, you get negative 6x. But if you add, that's negative 5, which is not positive x, so which means it's not going to be part of it. We also have negative x and positive. So there are so many factors, but you only need one pair that you're going to work with, that when you add, it will give you the middle term, and in this case, that's negative 2 and positive 3x. So these are the two factors that you're going to replace into the middle term. So this equation can be written as 2x squared. We now replace the two terms that we got, which is negative 2x plus 3x, negative 3 is equal to 0. All right, so now we've got a quadratic equation with 4 terms. Still on factorization, we are going to group into 2 terms. That's the first term, which is common between these two, that's 2x. So you're going to have 2x here. Factor out 2x, that's your dividing 2x squared divided by 2x, that's x minus 2x and 2x, as you can see, they are the same, so it's going to give you a negative 1. Between 3x and minus 3, what is common? That's a plus 3, so that we can obtain the same bracket as this one of x minus 1. So if we factor out 3 here, we've got x. If we factor out 3 here, we remain with negative 1. We equate to 0. So that's the concept. Once the brackets are the same, we've got x minus 1 and x minus 1. You factor that common bracket of x minus 1. You are left here with 2x, and on this part with plus 3, okay, which is equal to 0. So either one of these brackets must be equal to 0. So definitely x plus 1, when equated to 0, it is going to give us 1. Okay, let me write it. X minus 1 is equal to 0, or 2x plus 3 is equal to 0. So definitely x is going to be a positive 1 if you transpose to the other side. Or here, we can have 2x is equivalent to negative 3. If we transpose 3 to that side, then definitely you divide by 2 both sides. So that means x is going to be negative 3 over 2. All right, so these are the possible values of x that we could have determined by using the factorization concept. Let's see if we are going to have the same values if we are to apply the quadratic formula. All right, we have got 2x squared plus x minus 3 is equal to 0. Remember your quadratic formula, x is equivalent to minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's your quadratic formula. All you need is to have the value of a, value of b, and c from the quadratic equation. Ax squared plus bx plus c is equal to 0. So definitely here, our a, that's 2. Our b, that's the coefficient of x here, which is 1. And c is the constant, which is negative 3. So we can substitute into the formula. X is equivalent to negative b, which is negative 1, plus or minus the square root of b squared. So that's 1 squared here minus 4 times a. So a in this case, that's 2. All right, just open bracket there. Then we've got 2 here. What's okay? 7. Okay, times c, which is negative 3. All right, everything over 2 times a, which is 2 times your a, which is 2 times 2. So make sure you just present this formula fine. All right, so what you're going to do is to simplify what is inside of the square root. Just what is inside. Don't put anything. Don't put the square root. Just what is inside the square root. That's what we are referring to. 1 squared minus 4 times 2 times negative 3. You multiply these together, then you got a 25. So this will be the square root of 25 over 2 times 2, that's 4. All right, so from this part, definitely we shall have two possible values of x that we are going to have by separating the plus or minus that we have. Take note, we have got plus or minus here, so we're going to separate that. So you can just use your calculator, put in a fraction, that's negative 1, plus the square root of 25, everything over 4. All right, so that's the first answer, which is a 1. So x is equal to 1. All right, sorry, that's x is equal to 1, or x is equal to, you do the same thing, but here just change the positive, delete the positive and put a negative. That's negative 3 over 2. So you're going to have negative 3 over 2. All right, which is the same thing as what we got using factorization. So as you can see, if you are not given to leave your answer to 2 decimal places or 3 decimal places, that question you can actually work it with factorization. Yes, quadratic formula, most of you love to use quadratic formula, it's fine, but quadratic formula is best when you are attempting question 1.12, whereby you're given to solve this equation correct to 2 decimal places. There, you know definitely there is no way that you're going to do it. You have to use the quadratic formula there. All right, so that's our question. Let's see what you're going to have. Sorry for that. Okay, that's here. So this is 1.12. We've got x into 7x plus 2, which is equivalent to 1. So definitely, first thing, let us expand the brackets and see what you're going to have. So it's x and 7x, which is 7x squared, x and 2, that's 2x. Then you can transpose the 1 to the other side of the equation, which is going to be a negative 1. So that's the equation that you have. So having our equation just like the same format that I presented on the quadratic equation of ax squared plus bx plus c is equal to 0. It means our a is equal to 7, our b is the coefficient of x, which is 2, and c is the constant, which is negative 1. So you can apply our quadratic formula, which states that x is equivalent to negative b plus or minus the square root of b squared minus 4ac over 2a. So let's substitute our values, guys. Negative b, our b, that's a 2. So it's going to be negative 2 plus or minus the square root of 2 squared minus 4 times a here, which is 7, times c, which is negative 1. Just put in brackets. Okay, over 2 times a, that's 2 times 7. All right, so that's it. can obtain your possible values of x. So I always encourage you guys to simplify first this part under the square root, just this part under the square root, simplify everything. So you're going to have -2 plus or minus the square root of, we simplify that part, which is 2 squared minus 4 times 7 times -1, like this, which is 32. So you're going to have the square root of 32, everything over 2 times 7, that is 14. So from there, we can separate, okay, the plus or minus, just like what we did in the previous question. So that's it. And remember, your answer is supposed to be to 2 decimal places. So you're going to have a fraction, -2 plus the square root of 32, everything over 14, which will give us a decimal of 0.261. But to 2 decimal place, 1 cannot change the 6, so it will be 0.26. So this is going to be 0.26. Or x is equivalent to, we do the same here, we have to interchange that to a negative. So we put a negative here, which is going to be -0.546, and the 6 is going to change, which is 0.55. So it's -0.55 to 2 decimal places. So that was the question, guys. On this one, we can apply, yes, we can work with the completing of the square method. But most of us, guys, we are used to the quadratic formula. So, but we are going to do on another platform, work with the completing the square method, so that you learn all these methods, guys. You're supposed to know all these methods. All right. So let's check the 1.13, where we are given to solve. That's an inequality. So this inequality, there are so many ways that we could have used to solve this inequality. We are given that -x squared minus x plus 2 is less than 0. Okay, so that's a quadratic inequality that you're given, since the highest exponent there is 2. All right, so what are we going to do to solve such type of an inequality? Like I said, there are 2 possible ways that you can actually work with. You can ignore and just work as it is with a negative. But as for me, it's going to be a little bit weird to have the coefficient of x squared being a negative. So I'm going to avoid that. How do I avoid this to be a negative? I'm just going to divide by -1 each and every term. But knowing that we are dealing with inequalities, okay? Negative and negative is going to be positive. Negative and negative, that's positive x. Positive and negative, that's -2. Knowing that we are dealing with inequalities, the inequality sign is going to reverse. So it's going to be a greater than or equal to 0, like that. So you now have a new inequality written in this format. As we know that if we are dealing with inequality, you're supposed to find the critical values. So the critical values, these are the values of x that you find by solving the equation, not the inequality. You are now solving a normal equation, x plus x squared plus x minus 2 is equal to 0. You solve this equation so that you obtain the critical values. Then from there, you determine the solutions to the inequality. So take note, we have taken from inequality to an equation. Now you are solving an equation for x. So to solve for x, this is a quadratic equation. You can use your factorization, the quadratic formula. I don't know what is best with you, but factorization was the easiest way. And this time we have an advantage because the coefficient of x squared is a 1. So we just need 2 brackets here that we are going to equate to 0. And from these 2 brackets, we focus with the constant, which is -2. Okay, so we be having factors of x squared, which is x and x here. Then focus with -2. What are the factors -2? But if you add, you must obtain a 1, which is affecting x. So we've got a 2 and a -1. If we multiply 2 and -1, that's -2. If we add, that's a +1. So which means we have got +2 here and -1. So x is equal to -2 or x is equal to +1. These are the critical values. All right, with the critical values, what are we going to do now to find the solutions to this inequality? All right, you're going to make a sketch of the inequality, not the first one that you had here, because remember, you changed this inequality to this one. So you are now focusing with this inequality. That is, the coefficient of x squared here is 1, which is a positive. And we know that if a is greater than 0, which is a positive, if you're dealing with a being a positive, it's going to be a smiley shape like that. All right, so which means we shall have a smiley shape All right, just something of this nature. That's our X and our Y here. Our graph is going to cross at -2 and also to pass at +1 there. So we are going to have our quadratic with a smiley shape like this. All right, so this is the graph that we are going to expect to have for F. So where do we have this? If we are given x squared plus 2x plus x minus 2 is greater than 0, like it means f of x is greater than or equal to 0. And this is our f. Where do we see this f being greater than 0? It simply means where do we see our graph above the x-axis? Because this is where we have 0 and we've got -1, -2, -3, 1, 2, 3. So our graph here, where is it positive? It is going to be positive from 1 here going upwards. It's positive this side. All right. It's going to be positive here also from -2 going this side. It's positive because from -2 in this region, from -2 here to 1, it is in the negative region. This is the negative region. It's below 0, so it's in the negative. We need a condition where it is above 0. That's when it is a positive. So it's above 0 on this side. So we are referring to these values from 1, 2, 3, 4, 5 up to infinity. From -2, -3, -4, -5 up to infinity. These are the values when this graph is positive. So therefore, our solutions can be given as x referring to the values of -3, -4, -5. Let's compare these values with -2. What are they to -2? Are they greater than -2 or they are less than -2? These values, they are less than -2. But take note, there is an equal to there on our function. Okay, there is an equal to, so definitely it's going to be less than or equal to -2, or x is going to be comparing 1 with these values. We are comparing 2, 3, 4, 5. We can see that 2, 3, 4, 5, and so on, they are greater than 1, but we still have equal to. So our x is going to be less than or equal to 2, -2, or greater than or equal to 1. So these are the possible solutions that we are going to have. So as you can see, guys, when dealing with inequalities, it's much easier. Yes, you can deal with a number line. Yes, I'm going to explain that one. If we can have plenty time so that we know all the methods that you can actually use. You choose which one is best for you, but as for me, I prefer presenting on a graphical solution like that, on a graphical part. All right, the 1.14 we are given now to solve the equation. That's an equation having 5 marks. All right, let's see what we're given in this one. So for x, all right, let's see our equation. We've got 2 to the exponent of x. All right, I'm going to write it down here. We've got 2 to the exponent of x plus 2 to the exponent of 2 minus x, which is equal to 17 over 2. Solve the equation. Okay, dealing with exponents, this and that. All right, so you have to be very, very careful in dealing with these typical questions. The first thing that we can cross-check is this part where we are given 2 minus x. What is the meaning of this? Okay, let's get back to our exponents. X to the exponent of a by x to the exponent of b. If we are multiplying, we are going to add the exponents, which is a plus b. X to the exponent of a divide by x to the exponent of b is going to give us x to the exponent of a minus b, which is the same thing as x to the exponent of a over x to the exponent. You can write it this way. So here we are subtracting definitely, so it means we are going to have our format this way. If you want to use this way, guys, if you want to use it this way, take note, you maintain the sign as it is the negative. So it means this is going to be 2 to the exponent of 2 by 2 to the exponent of -x. That's if you want to use multiplication. But the best way is to divide, because that is where we are having a subtraction. So this can actually be written as 2 to the exponent of 2 over 2 to the exponent of x. So like I said, it depends with the way that you want to use. All right, so as for me, I'm going to write it with the division. So it's going to be 2 to the exponent of 2 over 2 to the exponent of x. That is the one that made us to subtract these exponents. We were dividing. All right, which is equal to 17 over 2. Definitely, this is now a fraction throughout. We've got a fraction, and this is same as over 1, which makes it to be a fraction. So what do? We know that definitely we need to clear fractions, and we clear fractions by multiplying by the LCM or the LCD of 1 2 to the exponent of x and 2, which is just multiply everything together. So you're going to multiply by 2 to the exponent of x. These are the two terms. Okay, here you do the same by 2 to the exponent of x. Here you do the same by 2 to the exponent of x. The denominators that you combine them together, those are the ones that you're going to use definitely to cancel out. Okay, so this will multiply each other, but here we've got 2 to the exponent of x affected by 2 to the exponent of x. So it's just like x times x. We know that that is x squared. So that is the same thing. We are going to have 2 by 2 to the exponent of x squared. Okay, we are multiplying the same thing. So it's going to be x. It's going to be squared, just like y times y is y squared. So that will be a squared there. All right. And here we're going to cancel. This will cancel out. So we are left with the 2 times 2 to the exponent of 2. So this is plus 2 to the exponent of 2 times 2, which is equivalent to, we can cancel also 2 and 2 here, which means you'll be left with 17 by 2 to the exponent of x. So this is what we have now in a simplified version or in a simplified manner. What can we do? We can simplify this part here. We can actually collect the terms together. These are just like terms, guys. So don't panic there. Those are just like terms. So you can simplify them because it's 2 to the exponent of 2 by 2. So you can even use your calculator. 2 to the exponent of 2 by 2, that's 8. So here we are going to have 2 by 2 to the exponent of x squared plus 8. All right, which is equal to 17 by 2 to the exponent of x. Then transpose this to the left-hand side so that it can be a negative. So you're going to have 2 into 2 to the exponent of x squared minus 17 by 2 to the exponent of x plus 8, which was already there, which is equal to 0. So this is what we have. So it depends with your mathematical skills, how good they are. But if you are like me or the rest of us, it is easier for you to introduce a certain letter than to work with these exponents as they are. Yes, you can work with them, but a lot of you guys end up making mistakes there. So what I'm trying to say, introduce a constant in place of 2 to the exponent of x so that it can be easier for you. This is 2 to the exponent of x here. Just introduce a constant so that it can be a normal quadratic equation that you are used to. So let any constant, so in this case, I'm just going to use k. So let k be equal to 2 to the exponent of x. So what does it mean? In place of 2 to the exponent of x, I'm going to substitute with k. So this will be a k here, but there's a squared, so it will be 2k squared. So we're going to have 2k squared minus, in place of 2 to the exponent of x here, I'm going to substitute k. So it will be negative 17k. So that's negative 17k plus 8 is equal to 0. So this is now a normal quadratic equation that we are used to, where we can apply our quadratic formula, factorization. I don't know which method is best for you, but as for me, it's going to apply the factorization method. Even though the coefficient of x squared is not 1, yeah, that means we're going to apply the longer way, whereby you need to inspect the factors, or if you do not want to inspect the factors, then do the longer way. You must multiply the first term to the last term. You won't even go wrong by this method. Okay, you just multiply the first term to the last term. That's 2x squared, k squared by 8, which is 16k squared. So what you need is to find the factors of 16k squared that when you add, they will give you the middle term, which is negative 17k. So we've got negative 16k and negative k. If we multiply this, we get a positive 16. If we add, we get a negative 16. Guys, if we add negative 16 and negative 1, that's negative 17, like this. Negative 16 plus negative 1, that's negative 17. So these are the two factors that I'm going to substitute into the middle term, which is going to be 2k squared. Into the middle term, I'm now substituting those two terms. So that's the idea, guys, just like that. Don't panic. All right, just like that. Okay, so what are we going to have? We are going to have negative 16k, negative k plus 8, which is equal to 0. So we just substitute these two terms into the middle term, which is negative 17k. Now we've got 4 terms, so we can group them into 2 so that we can factor out what is common for the first 2 terms here. 2 is common, k is common, so we've got 2k. 2k squared divide by 2k, which is going to be k minus 16k divided by 2k, which is a -8. We've got a negative here. So what you're supposed to do is to factorize on these two so that the bracket will be the same as the bracket of k minus 8. And what are we supposed to factor out? That's a negative, so that this can be a positive. So it's negative and k is going to be positive. Positive divide by negative, that's a positive. So this is actually -1. If you are to write it properly, that's a -1. So this will be -8 is equal to 0. As you can see, the two brackets are the same, just like what we saw in the previous case. We just have to take the common bracket, which is k minus 8. Then you are left with 2k minus 1, which is another bracket, is equal to 0. So this part, if you know how to do it short away by inspecting, then you can just write your answer to this stage, of which most of you guys, I see you having challenges here because I'm actually having grade 12 students. So I know this part. That is why I always advise you to use the longer way, which is this one that I was having here. All right, definitely you're gonna have two brackets equated to 0 here. I'm gonna use this space. I think it's gonna work. So k minus 8 should be equal to 0, or 2k minus 1 should be equal to 0. So definitely k is equal to 8, or here transpose the -1 to the other side is going to be a +1. So 2k is equal to 1 divided by 2 both sides. So k is going to be 1/2. Take note, these are not the values that we are being asked to calculate. Remember, the equation was for us to solve for x. In this question that we are dealing with, the whole of this question, we are solving for x. But here we solved for k, which is not part of the question or part of the equation. So what are we going to do? Remember, when we introduced k here, we introduced k at this stage where we said k is equal to 2 to the exponent of x. So that's the stage that we are going to start from, where now we have the numerical values of k. So we can introduce our k to say, since k is equal to 2 to the exponent of x, therefore 2 to the exponent of x is equal to the first k that we got, which is 8, or the same k, which is 2 to the exponent of x, is equal to the other k that we got, which is 1/2. So there we can obtain the values of x. Now we're back to exponents. How can we find the value of k? By just making sure that the bases are the same. We've got 2 and 8. So this is 2 to the exponent of x, which is 8, is 2 to the exponent of 3 in base of 2. So remember that if the bases are the same, I just have to equate the exponents. So x is equal to 3. So therefore, x is equal to 3. Or on the other side, here, put 1/2, where we know that x to the exponent of -1a is equal to 1/x. X to the exponent of -1 is 1/x. So 1/x simply means a number to the exponent of -1. So this means we're going to have 2 to the exponent of x being the same as 2 to the exponent of -1. So from there, just like what we saw here, the bases are the same. Definitely the powers are going to be the same, or the exponents, they will be the same. So x is equal to -1. So these are the solutions that we are going to have. That x is equal to 3, or x is equivalent to -1. So guys, as you can see, there's so many ways that we can apply or that we can use to solve these typical questions, but it's not much. It's not even much. You just have to apply your laws properly, and that can actually help. All right. Let's see the other part of the question. Let's see. All right. So we're gonna check the year. All right. The other part of the question is now on 1.2. Okay. Given the equation of a circle and the equation of a straight line, the graphs of the circle and the line intersect at A and B, determine all necessary, by showing all necessary calculations, the coordinates of points A and B. So A and B, these are the points of what? The point of intersection. So if I've got a circle here and a straight line, they intersect at two possible points. Let's say this is your A and this is your B. To find the point of intersection, we know that at this point, at the point of intersection, let's focus at A. The straight line and the circle will be having the same values of x, which means they are equal at that point, which is the same thing at B. The straight line and the circle, they'll be having same values at that point B, which means we are saying that the circle and the straight line, they are the same at that point. So if you are given this type of a question, it simply means that you're supposed to solve your question or your equations simultaneously. Okay, so at a point of intersection or at any point of intersection, solve the equation simultaneously. All right, so that's the case. We are going to solve these two equations simultaneously. So what are we going to do, guys? Okay, let's take it aside. That's 1.2. So we're given two equations on 1.2. The first one was of a circle, which is x minus 2 squared plus y squared, which is equivalent to 25. And that of a straight line, which is x plus 3 minus 3y is equal to 0. Okay, so we've got our first equation and our second equation here. So like I said, we are going to solve these simultaneously. Okay, it's easier by substitution. You just make any of the subject either from equation 1 or equation 2, but it was easier to work from equation 2. Yes, from equation 2, I can make x to be the subject here. All right, so make x to be the subject of from equation 2. That's x is equivalent to, if I'm to take 3, it's going to be a negative. So I'm going to start with a y here. So 3y to that side is going to be positive. Then 3 to this side is going to be a negative. So which means we now have the third equation. So what you're going to do, you're going to substitute equation 3 into equation 1. So you substitute into the equation that you never worked with. You worked with equation 2. That's where you made x to be the subject. Now you substitute into the other equation. You don't substitute in that equation that you have worked from. No. You substitute on the other one. All right. So being x being equivalent to 3y minus 3, that means I'm just going to substitute in place of x into equation 1. So thus we are going to have here x, which is 3y minus 3. So it's going to be 3y minus 3, but already there's a minus 2, which is there. So it's going to be minus 2. And also don't forget that there's a square there. All right, plus y squared. Y is just y, so there's nothing that you're going to substitute here, which is equivalent to 25. So there we've got a job to do to expand the brackets, but we have like terms inside the brackets, minus 3 and minus 2, which is a negative 5. We're going to have negative 5 squared plus y squared equal to 25. So let's expand the brackets. So in expanding brackets, someone might choose to expand the brackets, two brackets of 3y minus 5, 3y minus 5. Yes, it's fine. Or you can just expand direct, guys, using your identity. So remember, it's 3y squared, which is going to give us 9y squared, minus 3 times 5, that's 15. 15 times 2, which is 30y, minus 5 squared, which is 25. Remember, 5 squared, that's 25, plus y squared is equal to 25. Okay, so there just apply the identity, or you can expand it properly. 3y to 3y there, that's gonna be 3 times 3, that's 9y squared. 3 and negative 5, which is negative 15y, minus 5 and 3, which is negative 15y. Negative 5 and negative 5, that's a positive 25. So you collect like terms, minus 15 from your calculator, that's minus 30y plus 25. So as you can see, you're obtaining the same answer there. All right, transpose the 25 to the other side of the equation. As you can see, it be 25 minus 25, which is a 0. So those two, they will definitely cancel out. So you're going to remain with 9 plus y squared. Here is y squared, so it's same as 1 here. All right, so it's going to be 9 plus 1, which is 10. So we've got 10y squared by collecting like terms, and negative 30y. All right, so these are the values of y that you're going to have. So you're going to solve. It's a quadratic equation. The highest power is y is 2. And we can do it by factorization. Okay, so you can factor out, okay, because here this is equal to 0. Remember, this canceled each other. 25 and 25, they canceled, so this will be equal to 0. So you can factor out 10y is common here. So 10 divided by 10 cancels y squared, and y, you're going to remain with y. 30 and 10, that's negative 3, is equal to 0. So either one of these is equal to 0 from the 0 concept. Remember, your 0 concept is said that this must be equal to 0, or the bracket is supposed to be equal to 0. So if 10y is equal to 0, or y minus 3 is equal to 0, that means y is going to be equal to 0. From here, if we divide by 10 both sides, by 10 both sides, y is going to be 0, or y is going to be a positive 3 if we transpose to that side. So to find the values of x, we are going back on this part where we have our x being the subject. Remember, we have written our x as the subject to say x is equivalent to 3y minus 3. And we have the values of y that we determined here. The first value of y is as 0. So you're going to substitute that when y is equal to 0, x is equal to 3 into 0 minus 3. So that's x is equal to 3 times 0, that's 0 minus 3, which is negative 3. Or we move on to the other part where x is equal to, on a position where y is equal to 3. So you're going to substitute in place of y here, it will be 3. So that will be 3 times 3 minus 3, which is 3 times 3, that's 9 minus 3, which is 6. So x is going to be 6, or you can just use your calculator direct here. That's 3 times 3 minus 3, which is 6. So you've got the same values there. So therefore, these are the solutions that you're going to have. So therefore, x is equal to negative 3 and y is equal to 0. Okay, or you can write it when, you can write it this way. There are so many ways that you can write this here. You can easily state when x is equal to negative 3, y is equal to 0, okay? And when x is equal to 6, y is equal to 3. So that means this becomes a point when x is negative 3, y is a 0. So it's a point. All right, so it's a point which is negative 3 is 0. And another point when x is 6, y is 3. So these are the two possible points that you can have. So remember, we are calculating the point of intersection. The points, actually, these were the points, sorry, I need this. These were the points of intersection of a circle and a straight line, which is A and B. So from these 2 points, that's where we are going to have our A and our B. So you can just name first point to be our A and the second point to be B. So that was the question, guys. So the simultaneous equations, these are actually simultaneous equations. That's how these questions actually look like. So it's a matter of you guys working them stage by stage, expanding of brackets properly, and collecting of terms properly. All right, number 1.3, to finish up the question, having 4 marks. Show that the roots of the equation x plus m, x plus n is equal to 3p squared are real for all values of m, n, and p. All right, what type of a question is this? They are real. If they are real, then it means that the discriminant is supposed to be greater than or equal to 0. That's real, being real. They are just real. It's not about being rational or this and that. No, it's just about being real. All right, so let's have it here, 1.3. So for these roots to be real, it means that the discriminant should be greater than or equal to 0. When I'm referring to this, I'm referring to b squared minus 4ac should be greater than or equal to 0. That's the discriminant. So remember that you are given an expression which was x plus m into x plus n, that was x plus n here, is equal to 3p squared. This is our expression that we are given. From this part, definitely, guys, for you to have the b squared minus 4ac, you must have a quadratic equation, which is written in this format: ax squared plus bx plus c is equal to 0. But look at the expression, how it is presented. We do not have such format. So you are forced now to expand the brackets at least so that you can have this format that we have here. So you're going to expand the x and the x, that's x squared, x and n here, that's xn. All right, m and x here, that's mx or xm. I don't know the way that you're going to write it. M and m here, that's mn. All right, then we can transpose the 3p squared to this side. It will be minus 3p squared. As you can note on the quadratic equation, one side has to be equal to 0. One side has to be equal to 0. So the moment you transpose this, this will be equal to 0. So we now have the x squared. So we're going to collect x squared plus, we need the part of x. So the terms with x, we've got this part. There is x here. There is x here. So what are we going to do? We are going to factor that x and see what is going to remain, because there must be a term or an expression affecting x, we must see the x being visible. All right. So if we factor out x here, we are going to remain with n plus m or m plus n. It's just the same way you can write it as n plus m or m plus n. It's just like 1 plus 2, 2 plus 1. It's just one and the same, thing. All right. Then here on -3p squared, it's a constant. So there's nothing that you're going to do. It's going to remain as it is. That's a constant. Whether it's raised to the exponent or 4 to the exponent, that one does not matter. It's a constant. There is no x there. We do not have x. So it's a constant. So let's apply our formula and see if we are going to obtain something that is greater than 0. If we can obtain something greater than 0, that means we are obtaining a positive expression or a positive term or a positive number. That is what it means. So you must obtain a positive here. So the coefficient of x squared, that's 1. So that means this is our a, all right, and that's our b, and that's our c, which is the constant. So let's use our formula b squared minus 4ac. Let's see what are you going to have. So b squared minus 4ac is equal to our b, that's m plus n squared minus 4 times a, our a is 1, times c, our c is -3p squared. This is our c. All right, so let's see what are you going to have. So this is going to be m plus n squared minus, and a minus here is going to be a positive. So we're going to multiply negative times negative. That's a positive, which is positive 12p squared. All right. Looking at this expression, guys, let's check at this stage that we are. There's no need for you to expand brackets here because we are referring to the values of m, n, and p. If you are to substitute here, whether m is negative or is positive, if we substitute the value of m and n, we are going to square that value. Just like, let's say, we substitute -3 plus 2, then we square. Even if this is a negative, like -1 squared, the moment you square this, it becomes a positive. The same thing that is going to happen with p, whether p is a negative or it's a positive, once you square that value, it becomes a positive. So definitely that means this expression that we see here is a positive expression for any value of m, for any value of n, for any value of p, it is going to remain as a positive. So we are simply referring to b squared minus 4ac being greater than 0 because of this expression. It's a positive expression. So therefore it means m, it must be positive expression. All right, so our conclusion now is going to be show that for all real values, okay, show that the roots of the equation, all right, so therefore the roots of the equation are real here. So therefore the roots of the equation are real. Or thus the roots of the equation are real. So that is what we actually have in this case. All right, so it is how it looks, guys. And if it seems to be much difficult, then it means there is a need for more revision. If it seems more difficult the way it is right now, then it means there is a need for more revision. So tune in for more classes at Mason African Motives, and also revise from your textbooks, question papers, whatever that you can use, as long it is for the best of you guys to revise, let it be so. So that's it, guys, for Mason African Motives, working on grade 12 mathematics. Tune in for more of the classes, and don't forget to share our classes to your friends and colleagues so that they also can benefit from this information that we are having. And if you are new, don't forget to subscribe, share, and like our videos, comment, let us know the areas that we must work on that helps us to grow as a family, to reach others outside there, to benefit from this channel that we are having as a family. That's it, guys. Till we meet again.